Alright, in this question we're asked to find the integral from 1 to 5 of f of x dx, and we're given these two definite integrals that we already know. From negative 2 to 1 of f of x dx is 5, and from negative 2 to 5 of f of x dx we get 8. So we have these integrals, but we're asked to find this other one. Now, we need to apply some of the rules that we know. The problem is, I don't see 1 to 5, right? But I see negative 2 to 1, and I see negative 2 to 5. That makes me think that I'm going to have to use something where this 1 to 5 will be in the middle of negative 2 and 1, and then 1 to 5 will give us that whole thing, negative 2 to 5. That reminds me of the adjacent intervals property of definite integrals, which is this one right here. And that tells us that if we have the integral from a to some value, and then the integral of that value to b, that's going to be the same as the integral from a to b. And so in this case, I'm going to rewrite that using the values we have. We're going to say from negative 2 to 5, the integral from negative 2 to 5 of f of x dx equals the integral from negative 2 to 1 of f of x dx plus the integral from 1 to 5 of f of x dx. So we see, from negative 2 to 1 and then 1 to 5, that's the same thing as negative 2 to 5. Do we have all of these things? No, but we have some of them. I know from negative 2 to 1, that is here, and I'll highlight that in red. Negative 2 to 1 of f of x dx equals 5, and so we can replace that with 5. I don't know the rest though, so we're going to keep that. We still don't know what this is. What about on the other side? Do we know what that is? Yes, we do. I'm going to highlight that in green. We know that from negative 2 to 5, that's 8. So we get 8 equals 5 plus that integral that we're trying to find. We're just going to subtract both sides, and so we're going to end up with 3 equals the integral from 1 to 5 of f of x dx. And so we get that our final answer is